In this video, we're going to use properties of inverse functions to find exact values of certain composite functions. First, let's recall that when we compose a function and its inverse, that they undo each other. And using function notation, we can write this in the following manner. We can say f composed with f inverse of x equals x for all x in the domain of f inverse, and we can write f inverse composed with f of x equals x for all x in the domain of f. Now this property holds true for inverse trigonometric functions as well, and we can write the following 6 compositions. Inverse sine composed with sine of x will equal x, where x is between negative pi over 2 and pi over 2 inclusive. Sine composed with inverse sine of x will equal x, where x is between negative 1 and 1 inclusive. Inverse cosine composed with cosine of x will equal x, where x is between 0 and pi inclusive, and cosine composed with inverse cosine x will equal x, where x is between negative 1 to 1 inclusive. Then inverse tangent composed with tangent of x will equal x, where x is between negative pi over 2 and pi over 2 not inclusive. And lastly, tangent composed with inverse tangent of x will equal x, where x can be any real number. In this example, let's consider finding the exact value of certain composite functions. We have 2 parts to this problem, part A and part B, and this problem asks us to find the value, if any, of each of the 2 compositions. Now part A, the first composition, is inverse sine composed with sine of the quantity negative pi over 6. And we use the fact that inverse sine composed with sine of x equals x, where x is between negative pi over 2 and pi over 2 inclusive. And for part A, x equals negative pi over 6, which does fall in the interval of negative pi over 2 to pi over 2. Therefore, we can write that inverse sine composed with sine of the quantity negative pi over 6 will equal negative pi over 6. Part B is the composition inverse sine composed with sine of the quantity 2 pi divided by 3. And again, to evaluate inverse sine of x, we need x to be in the interval of negative pi over 2 to pi over 2 inclusive. Now for this part, x equals 2 pi over 3, which is not in the interval of negative pi over 2 to pi over 2 inclusive. Therefore, we cannot say that inverse sine composed with sine of the quantity 2 pi over 3 equals 2 pi over 3. Those things are not equal to each other. So in order to evaluate this composition, we need to use a different approach, and what we're going to do is look for an angle theta between negative pi over 2 and pi over 2 inclusive, such that sine of theta equals sine of the quantity 2 pi over 3. So let's illustrate this idea here. We're going to sketch an xy coordinate grid and draw the terminal side of angle 2 pi over 3 in quadrant 2, where the terminal side has a length of r and contains the point negative a comma b. And we know by definition that sine of the quantity 2 pi over 3 equals b divided by r. Now let's also notice that the reference angle is pi over 3, which lies in the desired interval of negative pi over 2 to pi over 2. So let's draw the reference angle of pi over 3 in an xy coordinate grid. And again, the terminal side of pi over 3 will be in quadrant 1, has a length of r, and contains the point a comma b. Well, by definition, we again know that sine of the quantity pi over 3 also equals b over r. And thus sine of the quantity 2 pi over 3 equals sine of the quantity pi over 3. Therefore, we can write inverse sine composed with sine of the quantity 2 pi over 3 equals inverse sine composed with sine of the quantity pi over 3, and that is equal to pi over 3. In this example, we're going to find the value, if any, of each composite function, and we have parts A and part B. Part A is the composition sine composed with inverse sine of 1/12. And we'll use the fact that sine of inverse sine of x will equal x, where x is between negative 1 and 1 inclusive. Now for part A, x equals 1/12, which falls in the interval of negative 1 to 1. Therefore, we can write sine composed with inverse sine of 1/12 is equal to 1/12. Part B is a composition, sine composed with inverse sine of 2. Now here, x equals 2 and is not in the interval of -1 to 1 inclusive. Now, furthermore, 2 is not in the domain of the inverse sine function, since there's no angle theta for which sine of theta is equal to 2. Therefore, we have to conclude that sine of inverse sine of 2 is undefined. In this example, we're asked to find the value, if any, of each composite function. We have parts A and part B. Part A is the composition, inverse cosine composed with cosine of 3. We're going to use the fact that inverse cosine composed with cosine of x will equal x when x is between 0 and pi inclusive. For part A, x is equal to 3. Since pi is approximately 3.14, then x equals 3 falls in our provided interval. So we can write inverse cosine composed with cosine of 3 equals 3. Part B is the composition, inverse cosine composed with cosine of 2 pi. Now here, x equals 2 pi is not in the interval of 0 to pi. Therefore, we cannot say that inverse cosine of 2 pi equals 2 pi. Those things are not equal. Instead, let's evaluate the quantity of cosine of 2 pi first. So we know that cosine of 2 pi equals 1. Therefore, inverse cosine of 2 pi is equal to inverse cosine of 1. Now, evaluating inverse cosine of 1 is asking, what angle of theta do we take the cosine of to get 1, where theta is between 0 to pi? We know that cosine of 0 equals 1, and therefore inverse cosine of 1 is equal to 0. So in conclusion, inverse cosine of 2 pi equals 0. In this example, we're asked to find the value, if any, of each composite function. There are two parts, A and B. Part A is the composition, cosine composed with inverse cosine of the quantity -0.21. We'll again use the fact that cosine of the inverse cosine of x will equal x when x is between -1 and 1 inclusive. For part A, x equals -0.21, which falls in the interval of -1 to 1 inclusive. Therefore, we conclude that cosine composed with inverse cosine of the quantity -0.21 equals -0.21. Part B is the composition, cosine composed with inverse cosine of the quantity pi over 2. Now here, x equals pi over 2, which is approximately 1.57 and is not in the interval of -1 to 1 inclusive. Now furthermore, pi over 2 is not in the domain of the inverse cosine function, since there is no angle for which cosine of theta can be greater than 1. Therefore, we conclude that cosine of the inverse cosine of pi over 2 is undefined.